Hi, we've got another repair video today. This is a hi-fi amplifier. This one's made by Acoustic Solutions, which I think is exclusively sold by Argos in the UK. And the fault that's been reported is that they have to give the amplifier a bit of percussive maintenance in order to make it work. So, you need to give it a whack before it starts working correctly. So, unfortunately, I've not been able to reproduce that fault. So it's been working absolutely fine for a couple of hours with playing music. And if I play some tones through it, you can hear it produces sound absolutely fine. So I don't know if just in the process of being brought over to my house that the components settled down, but there's probably a loose component in there or a loose connection. Maybe something's broken away from the solder slightly on the PCB. So we'll have a look inside and see if we can see anything obvious. And related to the original fault, this has a rotary encoder on the front. The knob's missing. It's still at the owner's house. But if you change the volume control, occasionally you seem to get an error on the LCD. So it says error U52. I haven't had a look yet to see if there's a service manual to see what those errors mean. But I also noticed that if you change the bass, treble, or anything that's stored in the non-volatile memory, assuming there is some, that gets lost when you power the device down and back up again. So it seems to set the bass to maximum, treble to maximum, balance to normal, and turns loudness on. So I don't know if they've exceeded the number of write cycles on the EEPROM, and whether the EEPROM is a replaceable part or whether that's something that's built into the microcontroller. We'll have to have a look. But even if we can't find anything wrong with it, it might be quite an interesting teardown just to see what they've put inside the device. So let's have a closer look. Right, so here we have the front panel of the amplifier, and you can see at the top here they have the volume level in decibels, and then the input selection is at the bottom here. If I turn on the tone generator, you can hear it's producing tone absolutely fine, but if I start tweaking the volume knob, you can see it is decreasing the volume, but you keep getting this error U52. And you also get a bit of a noise every time you twiddle the knob. I don't know if that's something that it's always done. I'll just bring the microphone closer to the speakers. Right, so I don't know if you'll be able to hear this. I'll turn the gain on the microphone up a little bit, but if I turn the knob, you can definitely hear a bit of beeping going on. So I don't know if you could hear that noise before, whether that's a new fault. I haven't used the amplifier before, so I don't know. That could just be poor circuit design or bad filtering of the digital circuitry that's close to the analog circuitry. And then just to demonstrate the failure of non-volatile memory, if we go to the bass setting, we'll set that up to 10. We'll increase the treble up to 10 and leave the rest of the settings as they are. And if I power it off now, and then power it back up, so the bass is now set to 4, treble to 8, so it's definitely not stored those values properly. So let's have a look inside the amplifier and see if we can see anything at fault. Okay, so I've just taken out all of the screws, so let's have a look under the cover. Okay. So we've got a nice big toroidal transformer here. We've got a little board here with a couple of filter capacitors, and I presume this is a fuse that we've got under here. Yep. We'll have a closer look at that. And then we've got what looks to be the power amplifier board, the input stage here, and then the digital board for controlling the functions of the amplifier. So here we have the mains inlet. This is 2-core mains flex, and it's passing through a grommet and cable tie. And then it's got a couple of passes through a ferrite core just here for a bit of EMI filtering. And then it goes onto this PCB here, which connects the transformer, the front panel switch, and the mains inlet here. We've got a glass 20mm fuse inside this little case. This should really be a ceramic fuse. I'm not sure if they've managed to get around the regulation by having it in this plastic enclosure here. And then we've got a couple of metallized capacitors. This one looks to be across the terminals of the switch to reduce the noise and arc on the switch contacts. And then we've got another capacitor this side, which I presume is just across the mains connection. And then we've got the toroidal power transformer here. This is just a single primary winding for 240 volt use, and then there's 3 wires coming off here, so there's a centre tapped secondary. I think on the label it's just right up against the casework, but I think it says 23023, so 23 volt secondaries and 240 volt winding on the primary. There doesn't appear to be a power rating on the transformer itself, although the rating plate on the back says 150 watts, so I'd assume this is a 150 VA transformer. And then we've got the main amplifier PCB, so we've got the rectifiers and bulk capacitors, we've got the amplifiers, some voltage regulators, and a bit of speaker protection here. So we've got the input here from the transformer with the centre tap as common. Then we've got a pair of filter capacitors just on the AC. Then we've got the bridge rectifiers. So these diodes are 1N5404s, so 3 amp diodes here. A couple of resistors here, presumably to discharge the capacitor bank. And then we've got the whole array of 22,000 microfarad 25 volt capacitors here for smoothing the DC. And the power amplifier chips that they've used on this amplifier are the ST TDA7296s. So I think I've used these in a project a long time ago. These are 60 watt Class AB monolithic amplifiers, just in a multi-watt 15-pin package. And these are really simple devices to use. The performance isn't great from them, but they just need a few passives around it in order to produce sound. And there's 2 of these on the board. These are just mono amplifiers, one for left and one for right. And if we just look to the left here, we've got a 7805 regulator here. So this is the main supply for probably all of the logic on the front panel, and this is also mounted on the heatsink with a seal pad here and an insulating washer here. A couple of small capacitors here for filtering and a big power resistor here. So what I'd assume they're actually doing here with this power resistor is dropping quite a bit of power in the resistor, because with a 23 volt AC supply, the regulated supply after all the filter capacitors here is going to be around, it's going to be over 30 volts, so to drop 25 volts just in the TO20 package is not going to be a great idea. So they're probably dropping some of the power in this resistor first, and then the remaining power regulated with the heatsink on the regulator. And then to the other side of the power amplifier chips, we've got a couple more regulators here. So we've got a 7808 here and a 7908, so plus and minus 8 volt supply. And these are just loose in the case and actually fairly close to the heatsink. And although the 7808 has ground as the tab, I think the 7908 it's either the input or the output which is on the tab. So if these were both to touch the heatsink, it would short out the supply. So that's not great. I would have liked to have seen those also screwed onto the heatsink, but that's a bit of cost saving going on there. And then just on the bottom left of the board here, we've got a big relay here for speaker protection. So I don't know if this is controlled purely by the power amplifier board or whether it's triggered by the front panel microcontroller. You can see we've got a transistor here which is presumably for driving the coil, but this is just a time delay so that the speakers, you don't hear a pop when you first turn it on as though all the capacitors are charging up. So this just briefly disconnects the speakers during power up, and then once the levels are stable it turns it back on and the speakers start working. And then if we just zoom out a little bit, we've got a chassis connection here, so it's labelled ground on the PCB, and then we've got a ring terminal with a shakeproof washer and a screw which is looks to be Loctited in. So this is providing the chassis ground. And then we've got an interconnect here between the power amplifier board and the preamp and input selection PCB. So we've got the left, right and ground audio signals in a bit of shielded cable here, and then we've got a 3 conductor ribbon cable here, which is labelled on the PCB as +8, -8 and ground. So that's what these 2 regulators on the power amplifier board are providing power to. So the dissipation in these is probably quite low, considering there's really nothing on this PCB. So these wouldn't have needed heat sinking. It would have just been nice to see these mechanically mounted just to stop them flapping about. And then just finally on the main PCB, we've got an interconnect here which is connecting the front panel to the power amplifier board. And then we have the input PCB here. So we've got the phono connectors on the back, we've got a whole array of electrolytic and ceramic capacitors here, so the inputs are clearly capacitively coupled into the amplifier. We've got a couple of op amps here, so these are JRC Japan Radio Corp 4558s, and those are dual op amps in a PDIP 8-pin package. And on the left here, this is the phono turntable input, so this is obviously a preamplifier to get the signal levels up to line level, and this is the line out connectors here. So we've got a op amp, stereo op amp here, just for buffering the output to something like a subwoofer or another amplifier if you were to daisy chain these amplifiers. And then we've got an array of film capacitors here, so these are the green capacitors, and space for 2, I think they're PT2314s. I assume these are surface mounted on the other side of the PCB, so these are all single-sided boards, but it makes sense that these are the input selectors. We've got a front panel connector here going to the front panel, and that's labelled ground, SCL, SDA1 and SDA0, so it's nice squared C interface to these 2 chips, and it looks like they're both clocked together, but they've got separate data lines so that it can talk to both of them at the same time. So I was just in the process of taking out this PCB ready for the next scene, and I noticed that this device with the part number PT2314 is labelled U52, and the error that we were getting on the LCD was in fact error U52. And this is communicated over I2C, so it would be possible for the microcontroller to determine which device on the bus was faulty. So potentially that error on the front panel is actually just meaning that this part is not working correctly. So, so this is a PT2314, which is a Princeton Technology Corporation 4-channel digital audio processor. And this has the treble and bass control, loudness function. It also has the volume control function built in. So this is possibly the device that's making that horrible noise on the speakers when you change the volume control. So that's presumably the I2C interface, and that's the noise that you can hear on there. But I'm going to have a quick look around this board because it does seem like potentially there's a loose connection on here, because if the I2C interface isn't working and you're having to give the amplifier a bit of a bang to get it working, potentially the loose connection is on this board and it's just not able to communicate with this one chip. So I'm just going to have a quick closer look at this and see if I can see anything obvious. So we're just looking here at the connection from the preamplifier board to the front panel connector, and it definitely looks like this pin and this pin have the solder connection to the header cracked. So this is an I2C interface, and it's probably not able to communicate with the chip properly, and that's why it's not able to store the bass, treble and balance controls properly, and why every time it was trying to change the volume you were getting an error U52. So I'm going to resolder this connection here, and I suspect that actually that's going to fix the problem altogether, and this will be why it wasn't working until you whacked in the amplifier and it caused it to be able to turn on the outputs, because this also has a mute control, which presumably it mutes the outputs while all of the capacitors are charging up at startup. And that looks a lot better. I'll just check over the rest of the PCB and check there's no other bad connections on that board. Okay, so I've just tidied up some of the solder connections on the board and removed all of the flux residue. I'm fairly confident that these solder connections were the fault in the amplifier, but we'll have a quick look at the front panel board and see what microcontroller they've used on there, just out of interest, and then we'll power it up and see if it works. And finally here we have the front panel PCB. And there's nothing too surprising on here. This is a single-sided board. We've got a whole row of tactile switches for the input selectors. We've got a connector here which goes off to our input PCB. Oddly, we've got a relay here for controlling the backlight on the LCD. So this is a 16:2 LCD with a parallel interface. I'm not quite sure why they're using a relay to turn the backlight on and off. And then we've got the infrared sensor for the remote control. So this is a fully integrated 38 kilohertz infrared receiver and demodulator, and then driving the whole thing we've got a PIC 16F876A with a 4 megahertz crystal here. Oddly, there's also a large potentiometer for controlling the contrast on the LCD. Surprised that they didn't just fit a pair of fixed resistors or even control it from a PWM output on the PIC. And then finally we've got the bulk capacitor for where power enters the PCB, some passives, the decoupling capacitor on the power pins on the PIC 16F, and then finally just on the right here we've got the rotary encoder. So I'll put all this back together. I might have a quick look to see if I can find another encoder, because the shaft on this is actually broken. I thought the knob had fallen off, but it's actually snapped. So I'll see if I can find another one, but I'll reassemble the device and we'll give it a final test. So I've managed to find a rotary encoder that's kind of the similar size. I'll just check that the pinout's the same, and then if it seems to be okay, then I'll see if I can fit this onto the board to replace this one which is broken. So the pin spacing for this rotary encoder was slightly different to the one that I'm replacing. So I've just soldered a bit of length of wire onto each of the pins, and this rotary encoder is actually mounted to the front panel through the lock nut, so it doesn't need to be soldered onto the PCB. So this can sit quite happily like that, connected to the front panel, and this should work as normal. So I'll just assemble the front panel back together again and we'll power up the amplifier. And for anyone that's not seen inside a rotary encoder before, let's see if we can take this one apart. So what we should see is a set of contacts in here, and the idea is that it produces grey code by producing two sets of signals which are 90 degrees out of phase with each other. So let's have a look. So inside here we've got the wheel, which is shorting out the that's providing the contacts for the grey code, and then here we've got a set of contacts here. So there's a common, and then there's the signal A and B. So I think this is the common pin here, and then this is A and B. And because these contact the pins here at different points in the radius of the circle, you get a signal which is 90 degrees out of phase with the other each time it brushes past the contact. And this is a mechanical rotary encoder, so this is a lower cost method of creating a rotary encoder, and just uses switch contacts basically to commutate the output to create the grey code. This is ideal for things like front panel controls where you're not rotating this shaft continuously, but if you're using it for monitoring the speed of motors and that kind of thing, you wouldn't use one of these. The contacts will wear out in no time, and that's when you start to use things like an optical encoder, which have a significantly higher lifetime. The lifetime of a optical rotary encoder is basically limited by the bearings that are used. There's no moving parts other than the optical wheel, and then it uses a pair of infrared photodiodes and infrared LED to monitor the rotation of the shaft. Okay, so we've got the front panel back on the amplifier. That was mildly infuriating to get back together, and there's a lot of screws. So actually the construction of this thing, although it's a fairly budget amplifier, it was constructed quite well. So let's turn on the device and see if we're still getting errors and whether the rotary encoder works. So it's plugged in at the mains now, and we'll turn on the power switch. And That seems to be okay. So sometimes when it was immediately powered up last time, it was getting the error code. We're not at the moment. Let's try turning the volume down. So the encoder seems to be working okay. That's a good sign. Let's try changing the bass. So we'll leave it on 10 and take the treble up to 10 and leave the rest as it is. Let's turn off the device and then we'll turn it back on again. And let's have a look. So the bass is at 10, treble at 10. So that all seems to be working properly. So I'll put the cover back on and just hook it up to the speakers, but I think we've done a successful repair. So I've put the amplifier back together again now. Everything seems to be working correctly. There's no problems with the rotary encoder. We're not seeing any of the error messages on the LCD anymore, and I haven't been able to get the amplifier to stop outputting audio, so everything seems to be all alright. It does make sense that something like that was down to a poor mechanical joint, considering that you needed to hit the device in order to get it to start working. So I'm quite happy with that. That's another device which has been saved from being thrown out. So if you enjoyed the video and don't want to miss out on more, please subscribe. Don't forget to give a thumbs up and comment down below. And thanks for watching.